Imagine cutting through the waves under a sleek, stealthy hull, representing the future of the Republic of Korea Navy. The next-generation warship slated for 2026 represents a leap forward in naval capability, blending advanced sensors, weapons, and crew comfort with state-of-the-art propulsion and signature suppression. Today we dive deep into an in-depth review of that ship, how it looks and feels, how it fights, and whether it's worth the cost. Externally, this warship introduces a radical departure from older, boxy silhouettes. The hull lines are sharp and angled, integrating radar-absorbent materials that minimize radar cross-section. The superstructure is flush, with fewer right angles, and many of the weapon mounts are recessed or behind stealth covers, giving it that great white shark appearance on radar. Reportedly, the ship is about 170 meters long and 21 meters wide, with a full load displacement near 8,100 to 8,200 tons. The prow is sharp, the deck is clutter minimized, and masts host integrated mast arrays rather than old-fashioned towers. The colors tend toward muted gray with low contrast patterns, again for stealth. Climbing aboard, the main deck and weather decks are made of non-magnetic, composite-influenced material to reduce signature. The hangar and flight deck area are sized to support an embarked helicopter for anti-submarine warfare, plus drone launch and recovery operations. The sensors are mounted inside low observable domes and panels. For example, phased array radar faces are built flush to the superstructure. Every opening, hatches, vents, intakes, is baffled or has infrared suppression to reduce thermal signature. Inside, the designers have placed emphasis on crew efficiency and comfort. Corridors are wide, ceilings are higher than in older combatants, and lighting is modular with dimmable LED systems. Noise insulation and vibration damping are enhanced especially in the living quarters and workspaces, so that the crew experience on long missions is less fatiguing. Command centers, Combat Information Centers, and CIC Combat Information Center rooms are fitted with large flat panels and holographic displays, integrated with AI decision aids and sensor fusion engines to reduce cognitive load on human officers. Redundant systems ensure that if one display or control station is damaged, backups take over. Below the waterline and inside the hull is where much of the magic happens. The engine rooms combine gas turbines and electric propulsion, a hybrid scheme, possibly CODLAG or advanced turbine electric integration, so the ship can cruise quietly on electric drive and sprint using gas turbines when needed. This dual mode gives fuel efficiency on patrol missions and high bursts when combat or interception demand. The acoustic signature is claimed to be significantly lower than generation ships, making it harder for enemy submarines to track. The sonar suite includes hull-mounted sonar, flank arrays, and a towed array system KSQR or equivalent, enabling long-distance submarine detection. Ammunition magazines, power systems, and auxiliary machinery are distributed for survivability. Shock hardening is built in, so the ship can absorb hits or near misses. As for performance, the top speed is estimated at up to 30 knots, around 55 km per hour, which aligns with earlier next-gen Aegis destroyer specs. The cruising speed in economical mode would be lower, say around 18 to 20 knots to maximize range. The endurance is expected to be several thousand nautical miles, enabling sustained missions in the Pacific or contested waters. Because of the stealth design and low acoustic signature, this ship is more survivable and less detectable by adversaries. Combat systems are among the most important. The vessel is expected to carry vertical launching systems (VLS) able to fire land attack cruise missiles like Hunmu series anti-ship missiles SSM-700K or successors, surface-to-air missiles including long-range SAMs and short-point defense systems, and possibly ballistic missile interceptors SM-3 or equivalent. Anti-submarine weapons include torpedoes such as the K745 Blue Shark lightweight torpedo. Close-in weapon systems (CIWS) protect against missiles or incoming threats at short range. Electronic warfare suites are robust, with advanced ESM, ECM, electronic support countermeasures, decoys, jammers, and cyber defenses. Some missiles are stored in stealth enclosures, and the radar coverage is 360 degrees, with multi-beam phased arrays. The ship can presumably coordinate in a networked fleet environment, sharing target data in real time with other vessels, UAVs, and command centers. In high-intensity combat, this destroyer is expected to perform multiple roles: air defense, anti-ship, land attack, anti-submarine warfare, and ballistic missile defense. Its sensor fusion, rapid decision loops, and weapon flexibility make it formidable. Against submarines, it can detect and prosecute threats at long ranges using its sonar, helicopter, and towed array. Against aircraft or missiles, the multi-layered SAMs and radar make it a strong point in a fleet defense ring. On survivability, its stealth reduces targetability, redundant systems avoid single points of failure, and damage control systems are modern. The hull is compartmentalized, with fire suppression, automated sealing, and emergency power systems. The ship is built for resilience in contested conditions. Now, about one of the trickiest topics: cost and value. While no official publicly confirmed price per unit is fully disclosed, estimates suggest that each of the new next-gen Aegis destroyers, or equivalent advanced combatants, is contracted around $540 million United States dollars. In one case, the second next-gen Aegis destroyer contract was 636.3 billion Korean won, about $540 million United States dollars. For the KDDX development program, the total cost is estimated at around 5.8 billion United States dollars for 6 vessels, or roughly $970 million United States dollars per ship, assuming equal division. These numbers are ballpark, and future inflation, integration costs, or specialized systems could push it higher. On the other hand, the ship is expected to cost less to operate than larger destroyers, thanks to its optimized design and smaller crew size. Compared to older Sejong-class ships, which have larger displacement and greater fuel crew demands, this next-generation craft may deliver better capability per ton. In terms of return on investment, the ship brings advanced stealth, multi-role flexibility, and survivability in high-threat environments. Its sensor fusion, weapons loadout, and networked operations make it a potent core asset in future naval operations. For a navy facing regional threats including submarines, missile attacks, and contested littoral zones, such a platform is essential. To sum up, this 2026 next-generation warship is a marriage of stealth, automation, flexible firepower, and crew-centered design. Outside it is stealthy and modern, inside it is ergonomic, digitally integrated, and hardened. Performance promises 30 knots, long reach, and detection dominance in submarine and air threat scenarios. And although the cost per unit is high, the advanced capabilities and optimized operations may justify it. In the coming years, as more public data emerges and sea trials begin, we'll be able to see whether it truly delivers. If you like, I can convert this into a more polished voiceover script or translate into Korean.